Hi, we're in Chapter 8. We're on the classwork, distance and ticket price. And today we're talking about the linear regression model. Question 1, they ask us to find r squared. Well, r is our correlation coefficient, so r squared would be the correlation coefficient raised to the exponent 2. Earlier, before we started this video, I did ask you to put your distance traveled in list 1 and your fare in list 2. We know in statistics that X predicts Y. So the distance you travel on a plane should predict the fare that you pay. Okay, that's what we're testing here. That's what we're talking about here. The distance traveled predicts the fare paid. So your X values are going to go in list 1. Your Y value is going to go in list 2. So take a minute and put those in there if you haven't already done so. So we have some summary statistics given. So the average of the X's, the average distance traveled is 853.7 miles. The average fare was $244.33. The standard deviation of the distance traveled would be 497.8 miles, and the standard deviation for the fare paid, $56.37. Our correlation coefficient, which is the R variable correlation, R equals 0.694. So to find R squared, we're just going to do 0.694 squared. Take a minute. And here we go. R squared is 0.694 squared, or 0.482. Explain what R squared means in context. Well, R squared, according to our Chapter 8 notes, is the percent variability of Y accounted for by X. Let me say that again. It's the percent variability of Y accounted for by X. Since Y is fare, the amount that you pay, and X is the distance traveled, we can say 48.2% of the variability in cost is accounted for by the distance traveled. Find the slope of the regression line. Again, let's take a look at our Chapter 8 notes. B subscript 1 is our slope. To find slope, we take the correlation coefficient R and we multiply that by the standard deviation in Y divided by the standard deviation in X. Again, looking at our Chapter 8 notes, the slope is R times standard deviation in Y divided by standard deviation in X. So the slope of our line is 0.079. Find the y-intercept. Well, B naught, that's what we call the y-intercept in statistics. B naught is equal to y bar minus the slope times x bar. Well, x bar is the mean of my x's. So this is my x bar, 853.7. Y bar is the mean of my y's. This is my y bar, 244.33. So plug it in, plug it in. So here we go. B naught, which is our y-intercept, is equal to y bar minus the slope times x bar. So here we go, we plugged it in, and we got the y-intercept of the regression line is 177.24. Write the equation of the linear model. In Algebra 1, we learned that the equation is y equals mx plus b. It's pretty much the same equation. We have slightly different variables. However, it's the same. And in statistics, we say y hat equals b naught plus b1 times x. where b0 is the y-intercept and b1 is the slope. So here is our y-intercept when x equal to 0, and here is our slope. So here is the linear equation for this model. Y hat, or the predicted value of y, is equal to 177.24 plus 0.079x. In statistics, generally we would write that equation using the units. This says the predicted fare is equal to 177.24 plus 0.79 times distance traveled. Use this equation to estimate the fare for a 200-mile flight. Again, we're going to plug it in. Wherever we see distance, we're now going to substitute in the number 200. And here we would get an estimate of the cost would be $192.96. We substituted in 200 for the distance that we'd be traveling. And finally, question 7, estimate the fare for a 2,000-mile flight. Again, we're going to plug it in. And instead of using 200 here, we're going to plug it in with 2,000-mile flight. $334.41. Before I leave, I'd like to show you how to do this in your calculator. Okay, so we had our X list in list 1. We had our Y list in list 2. So we're going to go to Stat, arrow over to Calculate, and we're going to go down to 2 variable statistics. This is the first time you've seen this in AP Stats. We have 2 different variables here. We have an X variable and a Y variable. When we hit Enter, we're going to get the statistics for each variable. Here is my mean of my X values, 853.72. That's the same as this number right here. Here's the standard deviation of my X's, 497.8. Here's the standard deviation of my X's. Here's the mean of the Y values, 244.33. And you see that number right here. Here's the standard deviation, S subscript Y, of my Y values, 56.4, or 37 as they rounded that to. Okay, I want you to go back to that Stat Calculator menu. And this time I want you to arrow down to linear regression. Now, truthfully, it doesn't matter which one you pick. This traditionally is the algebraic way you see linear regression, y equals mx plus b. And this traditionally is the way we would write it in statistics, b0 plus b1x. It does not matter. They're both going to give you the same equation. Okay, so if you hit Enter, you should get a menu that looks like this. Okay, and here our A represents our B0. So our B0 is 177.21, and I think we found that right here. It's a slight estimation error. Here is our slope, 0.079, 3 places after the decimal, and that's what I got right here, 0.079. Here is my R squared value, and here is R, my correlation coefficient. And just a reminder, if the absolute value of R is close to 1, it means it's a very strong linear relation. If R is positive, we know it's a positive association. If R is negative, we know it's a negative association, or we'd have a negative slope. Okay, tune in again for Miss Max Academy.